Hello, my name is Dennis Sujanic, and welcome to my lesson on volumes of rotation. This is one of the last units that are covered in the AP Calculus AB course, and it is subsequently one of the hardest. Therefore, I would like to go over it with you guys and make sure that it is understood, because it is always tested on the AP test. Volumes of rotation are when you have an area under the curve or an area between two curves, and you are rotating it about an axis. When this happens, it will create a figure, and then you are required to find the volume of that figure. So, with volumes of rotation, there are two main figures. There are disks and there are washers. These are what you will most likely be tested on. So for disks, disks are when one side of the region is always touching the axis of rotation. So for example, this would occur when f of x equals x squared, and on the interval from 0 to 4, for example, and it is always going to be touching the x-axis. So if you were to rotate about the x-axis, it would form a disk. So the formula for such a figure would be pi times the integral from your lower limit, which is a, to your upper limit, which is b, of f of x squared dx, which is very similar to what you would do if you were integrating the area of a circle, which is essentially what you are doing. F of x is going to be your radius, so since it is always touching, f of x is going to be your radius throughout, and since it is ever changing, you will have a consistent radius, so f of x will be required to be your radius. So that is the formula for a disk. On the other hand, you also have washers. Washers occur when the figure is not always touching the axis of rotation. So this could happen when it just touches at a certain point or diverges off after a certain point. And so you have this sort of hollow area that's in the center of the washer. And so, or in the center of the figure, so it becomes a washer. So this formula is similar to the one above. It is actually slightly different though. It is pi times the integral from a to b again, but this time it is f of x squared minus g of x squared, where f of x is going to be your top function and g of x is going to be your bottom function. So this could occur. This is usually what happens when you have an area between two curves that you are rotating about a region, and so it would almost always form a washer. But this could also happen. Let's say if you only have one function and you're rotating about an axis that is not the x-axis, something that is below the x-axis, for example, that will your g of x will be 0 at that point. And so we'll get into that later, but this is the basic formula for a washer. So when rotating about the x-axis, or what we're going to do is rotate about the x-axis and form a disk. So if we are given the function f of x equals negative x minus 4 squared plus 4, you are almost always given these problems on free response. And so on free response, these are likely the last questions to be asked, so they are usually part C or D. And so since they're so long and convoluted, they're hardly ever put on multiple choice because it's so time consuming. So before you are given these problems, you are almost always asked to find the area under the curve. So we should go ahead and get used to that practice. So find the area under the curves. It's simple. We've been doing this for half the year basically. Area should equal the integral from 2 to 6 f of x dx. Since this region is only bounded by the first quadrant, this is what you would do. You could do this in your with a pencil and paper, but I would recommend using a calculator for these just so that you can get the hang of it. And then once you kind of get the hang of it, then it's better to move on and go with pencil and paper. So most of my examples, there are a few examples that you can do by hand easily, but most of my examples, I will want you to use a calculator to get the hang of things. So when you find the area under the curve, you should get approximately 10 and 2/3, 10.667 units squared. Though I did not include the units squared on my presentation, you must always include it in your answer. Depending on how strict the grader is, he or she might want you to put units squared, or if any other units are specified, always make sure that you put the units just in case. It's better to be safe than sorry. And so also another fun fact that you should know, always round to the nearest thousandths place. If you do not round to the thousandths place, let's say you round to the 10,000ths or the 100,000th, or you just round to the ones place or tenths place, the grader will count off. It is in their rubric that they will require you to always round to the nearest thousandths place, even if it is a round number like 10.2. Well, it's not essentially round, but it's 10.2. It doesn't have a thousandths place. Always make sure to go ahead and put the 10.200. for example. So, following the finding the area of the curve, they will ask you to rotate this region about a given axis. In this example right here, I've asked you to rotate this rotate this region about the x-axis. Find its volume. So, use the same formula as before for the distance. The bottom part of this region is entirely touching the x-axis, which is the axis of rotation. It is a disk. So volume is going to equal pi times the integral from 2 to 6 f of x squared dx. So when you plug this into your calculator, again, you can use this by hand, and also I did just leave it as f of x instead of writing the entire equation out, just for sake of simplicity and space on the slides. But you will have to write it out entirely on the AP test. Put that into your calculator, and you should get a number that is approximately 107.233 units cubed, if I did my math correctly. Again, although I did not do it, make sure that you do put units cubed. So, rotating about the x-axis, but this time with a washer. So as you can see, with this is an area between two curves, and you are asking to rotate about the x-axis. As you can see, this region, it does not always touch the axis of rotation. It actually diverges right after 0. And so it's important to note that, it's important to note that it's a washer, so the formula will be slightly different. Again. Also, it is clear that your lower limit, since it is defined by the first quadrant, it is indeed, or your lower limit is indeed 0. But your upper limit is quite vague. You're not exactly sure what it is. So, though it is fairly close to 1, it is not exactly 1. And so with these, this one is intended to be a calculator question. So what you have to do is find where these two intersect. And so what you would do is you would just set f of x and g of x equal to each other, or graph both of them, see where they intersect. Should intersect at the point 0.942, 0.412. Also, I will have a question like this later on where you ask to find a point. Finding the point and the x-coordinate or y-coordinate are 3 completely different questions. If you were asked to find the point, make sure that you specify both the x-coordinate and y-coordinate in the proper notation, which is right here. They ask just for the x value or y value, just give those. That's all you need. Now, let's find the area of this. So, like I said, these are usually given on the free response, so they're asked in sequence. It's usually smaller questions leading up to larger questions. So first, let's find the area before we continue. Simple area formula between two curves. Area equals integral from lower limit to upper limit, f of x minus g of x dx. And so when you plug that into your calculator, you should get an area of about 0.591 units squared, if my math was correct. Also, finding the area does always help in finding the volume. It also gives, though it will not give you a number that is relatively close to your volume if you were to rotate it per se, like it won't necessarily give you a close number to that, but it will give you an approximation. So like let's say you had a volume of 1 and you were rotating it about an axis. Let's say you should get a volume of somewhere reasonable. So like you shouldn't get a volume of 10 if you have an area of 1 rotating about an axis. So an axis where it's just touching, like a disk, for example. It always helps to make sure that you know the area beforehand, because it lets you sort of estimate what your volume should be later on. Now, this was rotated about the x-axis as listed right here. Find the volume. Volume, again, it's the washer, so you have to use the washer formula. So volume should equal pi times the integral from lower to upper limit, f of x squared minus g of x squared dx. Also, never forget to multiply by pi at the end. That is something that a lot of people forget to do, and it's a common mistake to make because it's not technically part of the integral. It is a constant multiplied on the outside. So if you plug this into your calculator, you should get approximately 1.746 units cubed. Make sure to include units cubed if you can, if you remember. I highly recommend remembering. but that is the number that you should get, the volume that you should get if my math was correct. So, when you're rotating about an axis, or when they pose these questions to you, they don't always have you rotate about the x-axis. They could have you rotate about another axis, for example, y equals 2 or y equals negative 1. The process for finding these volumes is very similar. There's just one slight difference. You have to accommodate for the axis of rotation. So what you do is, I'll just continue reading for now until we get down to the formula. The process for finding the volume is still the same, however the equation is slightly different. Since the region is no longer lying on the axis of rotation fully, each of these figures will be washers. The washer formula will remain intact, but both functions will not have the axis of rotation subtracted from them before being squared. So the new formula will now be, it's similar to the washer formula, very similar indeed, or in fact, there's just one slight alteration. It's just f of x and g of x will now, or well, top function and bottom function will now have c, which I use as the variable for the axis of rotation subtracted from them. So let's say your axis of rotation was 2, it will be f of x minus 2 squared minus g of x minus 2 squared. But if your axis of rotation was negative 2, it'd be f of x minus negative 2 squared, which is equal to f of x plus 2 squared minus g of x plus 2 squared dx. So always make sure that you accommodate for the axis of rotation. So rotating about a y value other than the x-axis, we'll go back to the first problem that I have given you, just for ease of simplicity and making sure that we understand this concept fully with one problem, because when you can apply it to one problem, you can apply it to any problem. So finding the area under the curve, again, same process we did before, same answer. Shouldn't be any different. If you got something different, you probably need to check that out. If this region was rotated about y equals negative 1, which is underneath where the region is actually defined by the first quadrant, is what I meant. But so since it's rotated around y equals negative 1, this axis right here that I have marked for you, you see that there's this empty space right here that it's going to rotate around. So there's going to be this hollow area in the figure right in the middle. So you have to accommodate for that. So in order to find the volume, you just use the formula that I have listed for you on the last page. Volume equals pi times the integral from f of x minus negative 1 squared minus, so g of x minus negative 1 squared, which is equal to the equation that I have above. Since there is only one equation, f of x will remain the equation for f of x, obviously, but g of x will actually be where it's bounded by. So this one, if it's bounded by the first quadrant, the g of x will almost always be 0, since g of x is going to equal 0, y equals 0 at this point. That's where it's bounded by. That's technically your second equation, but they won't always satisfy that. They will just say that the region is bounded by the first quadrant sometimes, and that's something that you have to understand, and that's something that is implied. Excuse me. So it will end up equaling this equation I have for the volume down below, and you should get approximately 182.820 units cubed if I am correct. This question may be slightly wrong because this math was kind of done in my head. It wasn't entirely. I made a slight error earlier, and I had to fix it later on when I was recording this presentation. So it should be around 182.820. Not for sure. I'm pretty sure, though. It's very close to that, if not exact. Rotating about a y value with the next example that we had, the initial washer. Again, find where they intersect, same point, find the area, should be the same. If you get anything different, go back and check your math. If it was rotated about y equals negative 1, so again, this axis of rotation is below. That is important because there's also situations where axis of rotations are above, and that's a completely different process. So the axis of rotation is below. Again, use the same formula to compensate for that blank space that's in the middle, that hollow area or hollow volume. And so volume again is going to equal pi lower limit or integral from lower limit which is 0, upper limit which is 0.924. F of x minus -1, which is equal to f of x plus 1 squared. F of x is your top function, so it will come first. Minus g of x plus 1 squared. I went ahead and simplified that as I'm talking. Dx, and so g of x is bottom function, so it will be subtracted from the top function. Again, you must always compensate for the axis of rotation. The only time you do not compensate for the axis of rotation is if it is at the x-axis or y-axis. Plug this into your calculator, you should get about 5.457 units cubed. Also, if you notice, I will actually go back a couple slides. Right here, you notice that 5.457 units cubed is what happens when the axis of rotation is below, so it will actually have to travel a further distance around when rotating, so the volume should be bigger. If I can go back enough. Ooh, there's a lot of... So yeah, the volume should be, it was actually a lot bigger compared to the initial when it's just rotated about the x-axis, which is 1.746. So that's just a way to make sure that you're doing right. It doesn't give you the exact value, but it gives you assurance to know that you're headed in the right track. So if you got a smaller number than whatever it was, 1.47 or I think it was, or something like that. If you get a smaller number than that, go back, check your math, you know that you did something wrong. But if you got a number that's much larger than this, like for example 20, it also gives you an estimate that you're doing something wrong. You're like, hey, I need to go back, check that, make sure I did that right. Go back and check my math. Excuse me. So what if the region is under the axis of rotation, as I just mentioned prior? The formula will remain mostly the same. The only difference is that the functions are now subtracted from the axis of rotation. Also, I know this says special orientation. It should say spatial orientation, like S-P-A-T-I-A-L, has changed. So if you visualize it, if you're rotating about something that's above, if you kind of flip it in your mind, essentially reflect it upon that axis, that will be a 180-degree rotation. But you will also notice that your top function has now become your bottom function, and that your bottom function has now become your top function, and you need to compensate for that. So what you will do is, instead of the initial top function coming first, it will actually come second now. And to kind of explain that, I've also included the formula here. The formula is pi times the integral from a to b again, c, which is the axis of rotation, and since it is above, you will subtract the function from c, and since spatial orientation has changed, the bottom function will actually be subtracted first, so c minus the bottom function squared minus c minus the top function squared dx. And so I will have examples of these on the following page if you are not following. Again, like I said, we will be using the same examples to make sure that you understand. If you can understand on one, you can understand on all. So the region is enclosed by f of x and the x-axis, like I mentioned prior. If this region was rotated by y equals 5, which is up here, and I have it labeled for you, what would its volume be? So since it's just this region right here, this region, and you want it rotated over here, so you see that you have this, well, it's one unit right here, difference that's going to be hollow right here, and then the graph is going to continue right there, if you can sort of visualize that. And so it's asking what sort of figure will it make? Well, it would make essentially a cylinder with a hollow center with kind of like curve where it kind of concaves in. And so the volume for this would be, following that equation that I gave to you prior, pi times the integral from 2 to 6, which is also the same as 0 to 4 if you do know how this works, or if you do know how that works, just to make sure. That is also possible. So if you are having to do something like this by hand, it is simpler to do it from 0 to 4 because it will give you the same answer. Again, axis of rotation is 5, so 5 minus 0. 0 is the bottom function, which is the x-axis, so g of x equals 0, y equals 0. That is the second function. It is also the bottom function in this case. Ignore that answer. That was not meant to be shown yet. And then, so yeah, you have the bottom function. And then subtracting 5 minus the top function, which is f of x. I kept it simple as f of x. It was a lot to write out. It's a lot of programming to do. So 5 minus, or axis of rotation, minus f of x squared dx. And so when you integrate that, put it into your calculator, or if you do it by hand, you should get an answer of about 227.870 units cubed. Again, like I said, right here, you see that it's 0.870. Always make sure that you include the thousands place, even when it's a 0 at the end. graders will check for that. Also remember to put units cubed. It is something that I have forgotten to put in this presentation, but always make sure that you put it just in case. If units are not specified, sometimes you may not have to, but I always like to put units cubed, units squared, whatever the case may be. But if they do give you units such as centimeters, inches, miles, make sure you put those units, the correct units, because they will count off if you don't have the correct units. Next, back to this problem. Rotating about a y value that is above again. So in this case, I believe that we rotated about 1.5, right where they find where they intersect. Yes. Rotate about the value y equals 1.5. Find the volume again. So this again, same concept. Top function will now become the bottom function. Bottom function will now become the top function. Subtract those from 1.5. Square them each. So the volume should equal pi. Guys, it's going to go from 0 to 0.925. Axis of rotation minus the bottom function squared minus axis of rotation minus top function squared dx. But in your calculator, you should get 3.821 dx. You should get 3.821 units cubed. I apologize for that. And so with this lesson, I have also included a short homework section. It's nothing too much, but it's a additional question for each topic that we have covered thus far, with a challenge that I have included at the end. So with these, I have four. I have 4 problems, one over each example that we have done so far. So problem number 1, it is a simple area under the curve disk. When you rotate it, find the volume. Number 2, it's what we did most recently. It's area between the curves rotated about an axis that is above. Number 3, it would have been a disk if it was rotated about y equals x, or not y equals x, the x-axis y equals 0, but it is actually rotated below at y equals -1, so it is a washer essentially. A washer with the axis of rotation that's different. And then number 4, it's just a simple washer rotated about the x-axis, find the volume. And then number 5, I decided to include as a challenge problem. These aren't likely to be, you aren't likely to be tested on these in the AB section, but it is something that you could possibly be tested on because it still involves the same concept. With number 5, you are actually having to rotate around x equals 2, so you have to rotate around a vertical section. And so instead of rotating in a circle like this, let's see if I can include an example, like this, where this goes down, you're actually having to rotate it where this side goes the other way. So it's perpendicular to the x-axis, or well, perpendicular to the y-axis, I should say. And so with this, what you have to do is you have to, instead of having y equals, you have to solve for x and have x equal something. I didn't make the equation too terribly hard for this, just so that you can understand the concept, but then again, it is a challenge because you have to integrate with respect to y, which is a skill that sometimes you need to have on the AB AP test. So yes, you will have to integrate with respect to y, solve it, and then I have the answers following up shortly. Alright, so with the answers, I have this right here. I have the disk, just rotated using the simple disk formula. You should get about 43.145 units cubed. Number 2, I already went over how to do this. 5.102 units cubed should be your answer, should be your volume. Number 3, this number is fairly large, but it is correct. It also kind of makes sense because you can see that this actually goes up. If I can find my mouse, it actually intersects at its y-intercept is actually at 16, so it actually gives you a lot of volume, lots of space. So you should get a volume of about 720.079 units cubed. Again, number 4, simple washer rotated about the x-axis, 8.557 units cubed should be the simple answer. And then for the challenge problem, 0.868 units cubed. Though this number may seem very small, the region that you are given is also very small, and so when you rotate it, you'll also get a small volume. Alright, with the homework, I have also decided to give you a sample free response similar to the free response sections given to you on the AP tests. With this, I've decided to include 4 parts as they usually would, and then I actually have a 9-point grading rubric at the end with the answers. And so make sure that you follow this. This is very similar to the types of questions that they will ask you on the AP test. I tried to make it very similar to it as possible so that you can learn from experience, from someone who is experienced. So A, you are given dy dx equals something, a point, and then it asks for you to find a particular solution. You should know how to do that at this point. I will give you time to pause here for a second if you would like to view this sample response before I go into the answers. All right. So here are the answers. So for A, since you are given dy over dx equaling something and a point, you are asked to find a particular solution. That should always be the first thought going through your head. Also, it is noted that the graphs on the right are f of x and g of x, and it gives you g prime of x essentially right here. Make sure that you do not confuse this for g prime of x. It is labeled as g of x, which you will find in the first problem as I have given to you. Excuse my voice. So what you would do, isolate the variables, make sure dy and y are all on one side, x, dx are all on the other side. So what you would do, I gave you a point for separating or isolating the variables as they should be, and then integrating each side to solve for y and x. 1 point for setting up the equation. After that, if you integrate correctly, you should get y equals 2 radical x plus c. Solve for c with the point that I have given you, and then you should find that c is equal to 0. That is another point. Lastly, now knowing what c is, find the particular solution, find the solution for g of x. G of x should equal 2 radical x, or 2 square root of x. All in all, A was worth 3 points and is essential for the rest of the problem. For part B, I actually have made this free response section a calculator free response section. Most of the time, volumes of rotation are a non-calculator because they generally won't ask you to find the volume. They'll ask you to set up the integral, because sometimes finding the volume, typing that in on your calculator, and doing all the necessary stuff can sometimes be very time consuming. So they try to compensate for that by just making you set up the integral for it. But I have actually made you go ahead and made you find all the values for everything just so that you can get used to it, so that you're better prepared. I'd rather you have to be over-prepared than ill-prepared for the AP test. So for B, just asking when do they intersect, what you can do. Most of the time, you can just, actually not most of the time, sometimes they'll have you just put the point. On the other hand, most AP tests actually give you points for setting up the equation first. But what you would do to find this, you could do this and solve for it by hand if you're crazy. But what I would do is I would graph them on the graphing calculator, use the function or use that little tool, find where they intersect. About right here should be at 0.374, y equals 1.224. Also, note how I mentioned point. That does not mean just find the x-coordinate, just find y-coordinate. It means find them both. Now, you can leave them as this. This is acceptable, but you could also write them in proper notation where it's parentheses, x-coordinate, comma, y-coordinate, close parentheses. You get 1 point for the setup and then 1 point for the point, for a total of 2 points on part B. Part C, just saying find the area between the two curves, which we have already practiced, and I have already told you that will always be asked before. So what you do, just make sure to find the area between the two curves. Simple enough. Just integral from lower limit, which is 0 since it's defined by the first quadrant. As it's stated, bounded by the first quadrant. And then where they intersect, right here. Top function minus bottom function, dx. 1 point for the setup, 1 point for the answer. Notice how I also put units squared right here. You have to put units squared. Personally, I have met people that have counted off for it. I have met people that haven't counted off for it. So it's better to have it on there than to not. And lastly, find if it is rotated about the x-axis, what would the figure's volume be? Since it's rotated about the x-axis, you don't have to worry about the axis of rotation being different from anything. Just solve for it like a normal washer. Rotate around this way. Simple enough, follow the equation. Pi times the integral of 0 to 0.374. Top function squared minus bottom function squared dx. Solve for that. You should get 1.888 units cubed. 1 point for the setup, 1 point for the answer, for a total of 2 points. Now, together, most of your response questions are about 9 points. Sometimes some are more, sometimes some are less, but I'm pretty sure most of them are 9 points each. So I tried to mimic that as best as I could. Add up all the points that you got, put it right here, and that is the end of that. Thank you for joining my lesson on volumes of rotation. I hope you learned a lot. Thank you.